Let's review the calculations for subpanel and service loads, focusing on residential and commercial units. We will be talking about calculations for electrical circuits and electrical loads. The initial calculations had a few areas that could be clarified. Firstly, regarding general lighting, the 4,500 watts mentioned was the total for all three units, not per unit. Each residential unit's general lighting load should be considered as 1,500 watts. Secondly, baseboard heaters can be derated. Baseboard heaters are typically derated to 60%. Therefore, 10 heaters at 1,000 watts each would be calculated as 6,000 watts at 100%. Given these adjustments, let's recalculate the load for a residential unit. For Unit 1 and Unit 2, the loads are as follows. Firstly, general lighting at 1,500 watts. Secondly, two appliance circuits at 3,000 watts. Thirdly, a laundry circuit at 1,500 watts. Fourthly, baseboard heaters at 6,000 watts at 100%. And fifthly, other loads are at 75%, totaling 10,365 watts. With these values, the total load is 22,365 watts. To find the amperage, we divide the total watts by 240 volts, which equals 93.19 amps. Based on this calculation, a 125 amp panel would be sufficient for each residential unit, as the calculated load is well below that. When calculating the entire service, add the two residential units at 100% and then perform calculations on the commercial space separately. The total service ampacity should be the sum of these values. It's also important to consider a few additional notes, such as considering future load growth when selecting panel sizes. Electrical needs often increase over time, so planning for additional capacity is wise. Also, local electrical codes may require additional capacity for specific loads, such as electric vehicle charging stations or central air conditioning. These requirements can vary by location. Therefore, consulting local codes is essential. It is recommended that a qualified electrician always verify the calculations and design before any electrical work is performed. Electricity can be dangerous, and professional verification ensures safety and compliance. Let's delve a little more into the specifics of load calculations for each component. The general lighting load is typically calculated based on the square footage of the area. The NEC provides guidelines for this, specifying a certain number of watts per square foot depending on the type of occupancy. For residential units, this is generally a lower value than for commercial spaces, reflecting the different usage patterns. Appliance circuits are calculated based on the assumption that each circuit can handle a certain load. The NEC requires a minimum of two 20-amp small appliance branch circuits for the kitchen and dining area of a dwelling unit. Each of these circuits is typically rated at 1,500 watts, resulting in a total of 3,000 watts for these circuits. A laundry circuit is also required and is typically a 20-amp circuit rated at 1,500 watts. Baseboard heaters, as mentioned earlier, can be derated. The specific derating factor depends on the type of heater and the applicable codes. However, a common derating factor is 60%, meaning that only 60% of the heater's rated wattage needs to be included in the load calculation. Other loads can include a variety of appliances and equipment, such as refrigerators, dishwashers, dryers, water heaters, and air conditioners. The load for each of these items is typically listed in the appliance's nameplate. For continuous loads, which are loads that operate for 3 hours or more at a time, the NEC requires that the load be multiplied by 125%. This is to account for the fact that continuous loads can put a greater strain on the electrical system. After calculating the load for each component, the total load is then calculated by adding up all of the individual loads. This total load is then used to determine the required ampacity of the panel and the service. In addition to the load calculations, it's also important to consider the voltage drop in the electrical system. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the beginning of the circuit. Excessive voltage drop can cause appliances and equipment to operate inefficiently or even fail. The NEC provides guidelines for the maximum allowable voltage drop in electrical systems. It's also crucial to consider the short-circuit current rating of the electrical equipment. The short-circuit current rating is the maximum amount of current that the equipment can safely withstand in the event of a short circuit. The equipment must have a short-circuit current rating that is equal to or greater than the available short-circuit current at that location. The available short-circuit current is the amount of current that is available from the utility company's electrical grid. This information can be obtained from the utility company. Furthermore, grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electric shock. Bonding connects all of the metal parts of the electrical system together, which helps to ensure that they are all at the same potential. This reduces the risk of electric shock. The NEC provides detailed requirements for grounding and bonding electrical systems. It is also recommended that you coordinate with the local utility company. The utility company can provide information about the available short-circuit current at the service entrance and can also provide guidance on other electrical issues. Finally, always remember to obtain the necessary permits and inspections before performing any electrical work. Permits and inspections help to ensure that the work is done safely and in accordance with local codes. Now let's discuss the specifics of calculating the commercial load. Commercial spaces often have different electrical requirements than residential units. Firstly, the general lighting load is typically higher, reflecting the greater need for illumination in commercial settings. Secondly, commercial spaces may have specialized equipment that requires a significant amount of power, such as HVAC systems, refrigeration units, and industrial machinery. Thirdly, commercial spaces may have a higher density of electrical outlets and circuits to accommodate the needs of various businesses. To calculate the commercial load, you will need to gather information about all of the electrical equipment that will be used in the space. This includes the wattage of each piece of equipment, the voltage at which it operates, and the duty cycle. The duty cycle is the percentage of time that the equipment will be operating. Once you have gathered this information, you can use the NEC guidelines to calculate the total load. The NEC provides tables and formulas for calculating the load for various types of equipment. It's important to note that the NEC requires that the load for certain types of equipment be increased by a certain percentage. For example, the load for motors is typically increased by 25% to account for the inrush current that occurs when the motor starts. After calculating the load for each piece of equipment, the total load is then calculated by adding up all of the individual loads. This total load is then used to determine the required ampacity of the panel and the service. The commercial load calculation should also take into account any future expansion plans. It's always a good idea to overestimate the load slightly to allow for future growth. This will prevent the need to upgrade the electrical system later on. Let's now recap the key steps involved in calculating subpanel and service loads. Firstly, determine the general lighting load based on the square footage and occupancy type. Secondly, calculate the appliance and laundry circuit loads. Thirdly, factor in the baseboard heater load, applying the appropriate dirting factor if applicable. Fourthly, account for other loads, such as water heaters, dryers, dishwashers, and other appliances, considering their wattage and duty cycle. Fifthly, apply any necessary demand factors or dirting factors as per the NEC. Sixthly, sum up all the individual loads to determine the total load. Seventhly, divide the total load by the voltage to calculate the required amperage. Eighthly, select a panel and service with adequate ampacity to handle the calculated load, considering future growth. Ninthly, verify the calculations with a qualified electrician and obtain the necessary permits and inspections. By following these steps, you can ensure that your electrical system is safe, reliable, and code compliant. Accurate load calculations are essential for preventing overloads, voltage drops, and other electrical problems. They also help to ensure that the electrical system can handle the demands of the building occupants. In conclusion, accurate subpanel and service load calculations are critical for ensuring the safety and reliability of electrical systems in residential and commercial buildings. Consider all aspects of potential electrical usage, including lighting, appliances, heating, and specialized equipment. Remember to consult the NEC local electrical codes and qualified electricians to ensure compliance and optimal performance.